we've got a spool here for my stringless yo-yo experiment that we haven't yet made a video about, and a string. And so now what we're gonna do is we're gonna place the spool on top of the string and pick the string up. And obviously, because there's this gap in the spool, it's gonna pick the spool up.
Okay. You should probably speak a little harder because I can't hear you very well.
Together.
Bring the 2 points together.
And 2 places where I'm holding it.
Can you speak up?
The 2 places where I'm holding it. All right. Okay. So and now I'm gonna swing it. Now, what shape do you think it will? What shape do you think it will trace?
Like half a circle?
Yeah. Actually, it's a circular arc that it will trace. So.
It was a circular arc.
Right.
And now?
Because it's actually because if you take the 2 points that we just brought together, okay, then now actually then this string would be brought together as well, right? So in the string would be a distance. Now we're assuming that it can't stretch, it can't squish, it can only deform. And so that means this is a constant distance between the center of the circle, the places where I'm holding it, and any point on the circle, the spool.
Yeah. So it's drawing a circle.
What's the shape that? What's the only shape where?
I can't hear you.
What's the only shape where the distance between the center and any point on it is a constant distance?
The circle.
Or a circular arc, which is just a part of a circle. So that's why it traces a circular arc. Now, let's see what happens if I separate the 2 points where I'm holding it.
You separate the ends of the string.
Now this.
Oh, look at that.
The result here is a bit more surprising. Assuming the spool can move along the string.
Can't or can?
Can.
Uh-huh. So it's moving.
Yeah, move along the string. Surprisingly, it will actually trace out an elliptical arc.
Why is that?
Now, you need... Now, alright. Now, what do you guess these 2 points are?
The 2 foci of
an
ellipse?
The foci are the focus points.
Focus points of the ellipse?
Yeah. Now, Now, there's a fact about the ellipse. That is, if you take one of the foci, put a pin on there, and the other one of the foci, put another pin on there, and then put a rubber band on those.
Yeah.
And then take a pencil, put it in the rubber band as well, stretch the rubber band as much as you can, and then rotate the pencil little by little. What you'll get is an ellipse shape.
Then you draw an ellipse.
So
this is in fact what you're doing here in the air, right?
Now the other way to explain it is the mathematical way to explain it. If you take the distance between one of the foci and the spool, and then on to the other one of the foci, then what you get is that that's always, no matter what point you pick on the ellipse, it's always going to be the same distance. Okay, so now that we got that out of the way, let's try to and also we're assuming that the string cannot stretch, squash. It can only deform. All right, so now if we take our thing and deform it, you'll actually
It's not that easy, is it?
It isn't. Yeah. All right. So if you take our thing and change the location of the ellipse,
Yeah.
the distance will stay the same between one of the foci and the points on and the spool and the other one of the foci, which is exactly the definition of an ellipse. And actually, this is now. Why do we need to assume that the spool can actually move along the string?
Why is that?
Because the distance between, even though the combined distance between one of the foci and the spool and the other one of the foci is not changing, the individual distances between one of the foci and the spool and between the other focus points in the spool is actually changing.
And that's okay if it's changing.
So, which means, and assuming the string can't deform, the only way that can happen is by moving the spool around. And so yeah, that's why. Another nice thing this can produce is if we put the focus point back together, then what are we gonna get? Then the distance between one of the foci and the spool and the other one of the foci, well, if the foci are the same, then that's the same as the distance between one of the foci and then the spool and then back. And so that's not changing. Well, then that divided by 2, which is just the distance between one of the foci and the spool, is also not changing, which is the exact definition of the circle. So that means, so that also doesn't contradict the fact that a circle is a type of ellipse, just a special type of ellipse, where the two foci are just the same.
The same point.
Yeah, they're the same point. And so, yeah, so that is the string spool trick that the spool traces out an ellipse.
Thank you.